looks like a little exponent, but it's not. It's notation for the inverse, what's called the inverse of the function. Now, you can find the inverse in a couple of different ways, but I'm going to show you what I think is the easiest way to find the inverse. Okay? So the first problem looks like this. First thing I want you to do is change the f of x into a y. So you remember that from algebra, that f of x is the same as y. So we'll just make that a y. Now, here's the key step. Switch your variables. So write it x equals 2y plus 1. And then do whatever you need to do to get y by itself. Okay? So if I want to get y by itself, what am I going to need to do? Subtract 1. And then divide by 2. And now I have my inverse. And to be absolutely like 100% correct, I'm going to change back into function notation, but now it's the inverse. So instead of f of x, now it's f inverse. So remember the first step you did was change the f of x into y. The last step you do is to change the y back into f inverse, because that was your job, find f inverse. All right, let's try the next one. When I write it down, I'm just going to write y equals. Is that okay? Because that's my first step. Change the f of x into y. Okay? Who remembers what I do next? What did I do next here? After I got my y, the next thing I did was switch the variables. So x equals 3y minus 1 over 2. Now, I need to get y by itself. So what am I going to do? Kai, you want to put your head up, please? Thank you. What do I do? How do I get y by itself? Multiply by 2. Okay. And then add 1. Divide by 3. And then my very last step, change your y back into the function notation, but instead of f of x, it's going to be f inverse, because that's what you did. So you're just write f inverse equals 2x plus 1 over 3. Leilani, you want to introduce your guest?
Oh, this is my cousin Ryan.
Your cousin?
Yes. She is in middle school.
What grade are you in? 8? Alright, we good on that? Alright, let's see what's next. Well, it looks like the same thing.
Congratulations.
Alright, so can we get this started? I am going to write my problem, y equals 4x plus 2 over 9. Okay. What's the first thing I did? I changed my f of x into y. And then what will be the last step I do? I'll change my y back into f of x, only it'll be f inverse. Okay, what's the next thing I do after I get my y in there?
Change the sign, switch the sign.
X equals 4y plus 2 over 9. And now I start unwrapping things because I want to get y by itself. So I'll multiply by 9. Subtract 2. And divide by 4. put my answer in the answer blank, or when I put a circle around something, I'm not gonna use y, I'm going to use F inverse. Because that's, okay, so F inverse equals 9x minus 2 over 4.
Yeah.
Right, everybody? It's pretty easy, right? In a minute, we're gonna do one that's a little harder. Now, the next one isn't hard. It's different, but it isn't hard. We're going to write y equals the square root of x minus 2, okay? All right, what's the next step? X equals the square root of y minus 2. Now, this isn't hard, but it's different, because if I want to get y by itself, what am I going to have to do?
Square.
Square both sides. Because I can't get y by itself if it's underneath that radical. So I'm going to square both sides. So x squared equals y minus 2. Because if I square both sides, that goes away, right?
Yes. Plus 2.
And then I'll plus 2. And that is essentially the answer, but I need to go back to my function notation. So my inverse is x squared plus 2. All right, is that okay with everybody? All right. So now let's look at E. This one is harder because, I guess just because it's bigger. But everybody can get it started. What is step 1? After I change I got my y. Okay, what's my next step?
Switch the sign.
So x equals 2y plus 1 over 3y minus 4. Y becomes x becomes y. What do you think now? What should I do? Oh, that's an idea. Actually, what I'm gonna do is I'm going to multiply this guy over here. So I'm going to take this and I'm going to multiply it over here on this side. So I'm going to bring this over here, but because it's a division, when I bring it over, it becomes a multiplication, and I have this. All right, I need everybody to write that down and then look at it and make sure you get what I just did. I times both sides by 3y minus 4. That's what I did. So that went away. I brought it over here. Everybody okay with that? So I bring my denominator over. Now look at this. What do you think might be a good idea over here?
Distribute.
Distribute. So 3xy minus 4x equals 2y plus 1. Now I want everybody to look here for a minute, but not write this down, because I'm going to show you a mistake that's made a lot. We know we're supposed to be getting y by itself, right? That's our job. So what sometimes kids will do is they'll subtract the 1. Don't write this down, it's wrong. And then they'll divide by 2. Now, did they get y by itself?
Yes.
But what's the matter? There's still a y on the other side. That is not good. That can't happen. If you're going to get y by itself, then it has to be over here, and there can't be any more y's. Okay? So that is not what we do. Instead, what we do is we flip-flop these two terms. In other words, I bring this over here, so it's with the other y, and I take that over here because it doesn't have a y. So on this side, I want to have my y's. Anything with a y is going to be on this side. So I'm going to have 3xy minus 2y equal to 4x plus 1. So everything with a y has to be together. So you're going to move these things around so that all of the y's are on the same side. And if it doesn't have a y, it has to be on the other side. So things with y's, things with not y's. Just rearrange it. And it almost always involves flip-flopping these two.
So do we have to get the 3x over on the other side too?
No, because it's hooked to a y. So what we're gonna do now, once we get all the y's on the same side and all the things without y's on the other side, now we're gonna take out that y. It's like a GCF. So if I pull out the y, what will I have in my parentheses? 3x minus 2. Now remember, our problem earlier was we had 2 y's. How many y's do we have now? 1. How can I get it by itself? Divide by the parentheses. And y equals 4x plus 1 over 3x minus 2. For f inverse is 4x plus 1 over 3x minus 2. Okay? All right, let's try. I gotta erase this. We're gonna do another one to pick up all my space. All right, what was the first thing I did? After I switched my variables, x's become y's.
Multiply.
I brought my denominator over. I distributed. And then I started moving things around so all the y's were together and the other things were over there. Then I factored out the y and divided to get it by itself. Okay? Now, let's see how you do with this next one. We're going to go through those exact same steps. Alright, who knows what step 1 is? Flip up, I switch my variables. So x equals 8y minus 2, 4y plus 1. All the x's become y's, all the y's become x's. Okay. Now what?
Alright, multiply the bottom, the denominator.
This guy over to here. So I'm gonna have x, 4y plus 1 equals 8y minus 2. So this is a parentheses that's gonna come over here. I move him over here. When I move him, he becomes a times, because that's a divide. All right, everybody okay with that? What happens now? Distribute. So 4xy plus x, you're distributing here, equals 8y minus 2. And then this is the step we sometimes forget. What has to happen now?
Yeah, you changed the.
We gotta move. Because we have to have all of the y's on the same side. When I bring this guy over, will you agree he'll become negative?
Yes.
And when I take this guy over here, he also will be negative. So 4xy minus 8y,
equals
negative x times 2, or negative 2 minus x, the order doesn't matter. Everybody see what happened? Now, why did I do that? So that both my y's were together, and now I can
take out a y.
take out a y. Now I can take out a y. Now, you might notice that you actually could take out more than a y from this. If you were going to factor this, you could take out more than a y. Would everybody agree with that? But don't, because what am I trying to do? Get y by itself. So I just want to get the y out, not anything else. Okay, then I'll divide. And my answer is negative x minus 2 over 4x minus 8. Change it back into the function notation, which is a formality, and that's my answer. Okay, how do we feel about that? Okay, I need you to have a sheet of notepaper then. Next time we're together, we're gonna have a quiz, one problem, and it's gonna be just like this. Okay, so we're gonna practice right now. So get out a sheet of paper, or some kind of paper somewhere that you got. And you can use your notes, you can help each other, but let's see if you can. Ultimately, this is what you're gonna answer right here. This is what you're gonna answer. Okay? Here's your problem. Here you go.
Is this the inverse one?
You're finding the inverse. This is what you're trying to find right over here. So this is your problem. So see how much you can remember without looking at your notes. You're gonna go through the same set of steps that we just went through. By the way, I don't see you guys tomorrow. So if you want to take the quiz early, there'll be one problem just like this. I mean, we'll do it on Monday, but if you don't want to wait that long, because it's a long time, you can come in tomorrow for office hours and take it, or you can take it today after school or tomorrow after school.
You say it's just one problem?
One problem, because what I'm gonna have you do is get out a sheet of paper, I'm gonna write a problem on the board, you're gonna write it down, you're gonna do it. Okay? Oh, Naz is done already, we're gonna see if he's right or not.
Yes, sir. Boy.
What was the first thing you did, Naz? So, you don't have to write, you don't have to write this step down. But you do have to write this step down. All right, is everybody okay with that first step? All right. Cole, what did you do next?
Multiply 7y plus 1 times x.
You brought this over here, so x times 7y plus 1 equals 2y plus 3. So he brought the denominator over,
Yes.
right?
Yes.
And then Kendall, what's the next thing we do? Distribute. So 7xy plus x. Don't forget when you distribute, guys, the whole point is both right? Alright, Cliff, what happens next, once we get done distributing? Well, I'm not ready to divide just yet. What do I need to do first, Celeste? Remember, Cliff, I gotta switch these guys because ultimately I have to have my y's on the same side. So this is gonna be 7xy minus 2y. Okay, guys? I'm bringing the y over. So it's gonna become minus 2y. Bringing the x over, gonna become negative x. And now why did I do that? So I could factor out my y. And then I'm gonna divide. And it's really, really important, guys, you recognize this is what you're dividing by. So when you build your fraction, that's the denominator. Negative x plus 3 over 7x minus 2. How many of you got that far and got that done? Super. All right, we're gonna do one more. Do this one a little differently though. I'm gonna put it up here, and then I want a volunteer to come up and do the first step, and then we'll have another volunteer do the next step, and we'll just go through it step by step.
What?
Don't do that.
The last one we did was real rough.
All right, here we go, and our goal is to fill in this blank. Okay, here comes the first step right here.
Oh, wait, we're doing it, or?
Yeah, you should be doing it too, but instead of me doing it, I'm gonna have different volunteers come up and do one step at a time, okay? There's step one. All right, okay, Lincoln. Lincoln's gonna do the next step.
Can I do step 4?
Yeah, yeah. No, it's good. Yeah, that's okay. Yeah, I said you didn't have to do that one, because you did that first.
Good. Oh.
Okay, so Lincoln did, he brought his denominator over and then did the distributive. Are you okay with that? Are you okay? Perfect, all right. Who's next? All right, Amy. Next step, here we go. You know what to do, hopefully. He's drawing the arrows, I love that, because he knows he's switching sides, right? When you switch sides though, remember, the sign changes. So if it's positive over here, it's gonna become a minus, right? If it's a minus, it's gonna become a plus.
Oh, that's what I was thinking. I was missing step.
Okay, you all right with that? Perfect. All right, I need another volunteer, okay. Abby.
That's money.
So, it's kind of small there, these guys get smaller as we go. They, she factored out the Y. Good? Ilani? Sure. And we have one more step to go. He is going to,
Oh, that was just my math over
and then we're gonna write that in the answer blank up here, right?
Yes, ma'am.
So F inverse equals
2x.
2x minus 7 over 3x minus 8. Does everybody feel comfortable with that?
A little bit.
Okay. Next
Look,
time,
comfort.
Monday, one problem, you'll do this exact thing, okay? You can do that today or tomorrow after school, or tomorrow before school, if you don't want to wait till Monday. Okay. Thank you to the volunteers. Now,
I didn't know that.
Yeah, we
How you look?
number two, we have more to learn, guys. But again, the little quiz we have will be one problem. Right, try to answer. All right, number one, I have 3 pictures. One is a parabola, one is a sideways absolute value, and one is a line. And we are being asked 3 questions. The first question is it a function? All right, number 1, is it a function?
Yes.
Yes. Because it passes the vertical line test. Remember, if I draw a vertical line, I only hit one place. One place. Is this one, I'm gonna say yes, passes vertical line test, VLT, vertical line test. Alright, what about this guy? Is he a function?
Nope.
No. Fails vertical line test, because when I pass a vertical line down through this picture, you see where it hits there and there? Not good. Hit one time. Is this a function?
Yes.
Yes. Passes vertical line test. Number 2. Is its inverse a function? Now, to answer this question, we have to do the horizontal line test. The HLT, the horizontal line test, talks about whether the inverse is a function or not. So, what did we use the vertical line test for? The original picture. The original picture. Does this pass the horizontal line test?
No.
No. So, no,
Fails.
fails, HLT. Is this inverse a function? Yes. It passes the HLT. How about this one? Is this one, is the inverse, I'm talking about the inverse now, is the inverse a function?
Yes.
Yep. Passes HLT. Now vocabulary. Last question, number 3 says, is it 1-to-1? 1-to-1 means you pass both tests. If you're 1-to-1, it means the verticals hit once and the horizontals hit once. Okay? So, is this one 1-to-1?
No.
Nope. Doesn't pass both. Is this one 1-to-1? Nope. Doesn't pass both. Is the last one 1-to-1?
Yes.
Yes. Passes. So on test day, when that comes, I'll draw a picture and I'll say, is this 1-to-1? And the first thing you will do is draw vertical lines down through it. Does it pass? If so, okay. Then horizontal lines. Does it pass? If yes, then we're 1 to 1. Pass both. 1 to 1. Listen to the vocabulary. 1 to 1. 1 vertical line, intersection, and 1 horizontal line, intersection. Okay. Now, sketch the inverse. All right, everybody good with this? 1 to 1. Pass both tests. Now, this next one, you are actually going to graph the inverse. So here's what I want you to do while I am getting my picture drawn up here. I want you to label each point. So like this point right here is the point -1, 0. So on your paper, I want you to go ahead and label every single one of those points I put on it. And my graph isn't so great, so just get as close as you can. I think these are supposed to be down just 1, so I think this is -2, -1, -3, -1, and -4, 0. I know the picture's not very good, just go with it. So I think those are the points. I noticed on the test, some of you have trouble getting the points labeled. Remember, it's always X, Y. So it's always how many steps horizontally and then how many steps vertically. X, Y. So do those points look okay to everybody?
Yes, ma'am.
Now I'm gonna graph the inverse, and you're gonna be amazed at how easy this is. The quiz we take in a couple of days, or tomorrow, or whenever you take it, you're gonna find the inverse of an equation. And once you get your y in there, what is the very first step to writing the inverse? You switch the x's and y's. That's what you do with your ordered pairs. So, see this point right here? He's -4, 0. When I graph the inverse, I'm going to flip those, and I'm going to graph 0, -4. So 1 point at a time. All right, so what's this one? Well, he's -3, -1, so I'm gonna graph -1, -3. And then I'm gonna graph -1, -2. You see what I'm doing? I'm just turning these points around. So -1, -2. And then what do I do with this one? 0, -1. So look what happened, guys. You don't have to label all these IM, but you don't have to label these pinpoints. Just get them on there in the right spot. Look what happened. What shape did I have over here? Little trapezoid here. It's called a trapezoid. But where is he now? Now he's on the Y instead of the X because I switched my variables. That's what I do when I find an inverse. I switch the variables. All right, so I've done these so far. Okay, what's this one gonna be? 1, 0. What's this one gonna be? 0, 1. So look what you just did. just made that triangle, but instead of being like right side up like this, now it's sideways. And now I need 2, 2, that point isn't gonna change, it's gonna stay 2, 2, and then 0.
Lord is blessed.
Graphing an inverse is so easy. All you have to do is switch the ordered pairs. Right? So instead of 3, 0, I graphed 0, 3. Everybody okay? Well, hopefully you're looking at the next one and trying to figure out what's going on there. I only have 3 points, so I have -2, 0. Go ahead and label them, guys. I have 0, 2, and I have 2, 0. I think it really, really helps to take the time to label these original points. All right, -2, 0 is going to get graphed at 0, -2. 0, 2 is gonna get graphed at
2, 0.
2, 0.
Okay, guys.
And 2, 0 is gonna get graphed at
0, 2.
0, 2. Now connect your dots with the same shape that you had to start with. So I started with a semicircle. So when I connect them, I'm gonna get a semicircle, but because I switched the variables, I'm not sitting on the x-axis now, I'm sitting on the y-axis. Easy peasy? All right. Number 4. All right, I have a couple of equations. These are called parametric equations. Notice that I have 2 of them, and one is x equals and one is y equals, but they have another variable in them called t. And the reason that's called t is because normally when parametrics are involved, time is involved. So normally t would be for time, not always, but that's why it's t. Okay, now look at the directions. Find x comma y. If we let t be 1, this is so easy. If t is 1, can I find an x value? What would it be? 3. How did we get 3?
Plug in.
We let t be 1. It's a plug and chug. Plug in 1. What would my y value be?
Negative.
-3. Done. That was it. That's all you had to do. All right? Now you do the second one while I'm copying it down. You do the second one. Same thing. Different equations, but same idea. You're finding x and y. got 2,49. What about the rest of you? Does that look right? Groupies, if we put 7 in, what's 7 minus 3? And the square root of 4 is 2? If we put 7 in, 7 squared is 49? Got it?
Yes, ma'am.
Number 5.
And then where's
7 times 3.
I'm so hungry.
brother?
I think it's time to rock.
These directions always blow my mind because it sounds like really nappy. Find the direct algebraic relationship between x and y. What that means, write this down next to those directions so you remember. What that means is eliminate t. We want a relationship between x and y. We do not want any more t's. We're going to eliminate the t's. Now, I want you to think back to Algebra 1 when you used elimination to solve a system of equations. You remember how that worked? If I want to eliminate the t's, first of all, I'm going to line this up a little bit nicer. I am going to add these two equations together, and I want the t's to disappear. Now, they're not going to disappear right now, because 3 minus 2 is 1. I would still have a t. So you remember what you do? You multiply to make these two numbers the same.
Yes.
So I'm going to multiply my top equation by 2 and my bottom equation by 3. You see what will happen? That'll make that a 6, and it'll make that a -6. And when I add, they're gone. And that's my goal. Get rid of them. Get rid of the t's.
When you like move the T, it be the 2. Do you not move the negative sign?
Okay, what do you mean?
Like, because it's a negative 2T, do you not move the negative sign with it?
Now here?
Yeah.
No, because I want one to be positive. That's gonna be a positive 6t, and this is gonna be a negative. And that's the only way they'll cancel. If they're both positive, they won't cancel. So I need these to cancel. So my equations now are 2x equals 6t plus 2. Is that okay?
Yep.
And 3y equals negative 2t. Either leave it blank or put plus 0. There's no number there. Negative 6t. 3 times 2 is negative 6. That's the whole point. Now, when I add, here's my equal sign. When I add, those are gone. And what's the only thing I have over here?
2.
2. When I add, remember this is an add,
2x.
I'm gonna have 2x plus 3y. Those don't combine, I just have to write 2x plus 3y. And believe it or not, kids, that's your answer. Because what did the directions say? Find a relationship between x and y. That means find an equation that has x and y. No t's. Eliminate the t's. All right, we'll do one more and then I'll stop for the day. Here we go. Take a look at it. You've got x equals t plus 4 and y equals 7t minus 3. Now remember, your goal is to add these together and have that cancel out. What can we do to make that happen?
Times -7 on top.
Times the top one by -7. Does everybody see that? Because that's going to give us -7x, -7t, and -28. don't do a thing with the other one, because when you add, do you see that going away? And that's your goal. So you multiply by whatever you need to multiply by to make that happen. All right, so what do we got on this side of the equals? Negative 7x plus y. What do we have on this side of the equals? Negative 31. There's your answer. Direct algebraic relationship between x and y. All right,
That
we've
was-
got one more of those to do next time.
You guys have one more.
So we have one more problem to do. So technically, I'm not gonna assign that homework, but you could do it now. You could do it now. The homework, yeah. I'm not assigning it yet because we